Hello, physics. We are going to start here at section 3 of chapter 17, page 596. And before we dive into the topic, I want to show you a few things. Here's our classroom shop vac, and I took off the top a little bit so that we could see the specs of this motor. And you can see here that the voltage is 120 volts. It takes 12 amps of electricity. You can see next to the volt a little squiggly line, which is 20 volts alternating current, and that it takes 60 hertz, that's 60 cycles per second. Here's another electrical device. This is the monitor for the computer. And you can see on the back here that it takes 19 volts alternating current, and then it goes to 1.58 amps. 1.58 amps, which is not very many. Here's our classroom freezer, and the label's on there sideways, but you can see that it takes 5 amps of electricity, and 15 volts is about the same as 120, and 60 cycles per second. So back to our section here on current and resistance. Current is simply the movement of electric charge. That is current. So when we're looking at those appliances, one of the things that was showing you there is how much current, and how do they show you that? Well, the unit for current is amps. And so you saw in some of those units different amperage that the electrical appliance will take. How many electrons are actually going by? Now, the amp is a relatively large unit because it's based on the coulomb. And so if you have 1 coulomb going by in a second, a coulomb being very large, that means there's a lot of electricity going through. And so 1 amp is a lot of electricity. But that's not the only component that determines how much energy is going through a system. So we'll talk more about that. But I'll tell you a little story here related to this guy, Luigi Galvani. He first discovered there were electrical currents in the body because he discovered that when he was making some electrical sparks, it made the legs of a frog move that he had recently dissected. You have electrical impulses going throughout your body, and this is one reason why you see in the movies sometimes where they'll shock somebody with their heart and so forth. And keep in mind, that's to stop the heart, not to start the heart. Many years ago, in a different country, I was doing a frog dissection for biology, and we had pithed the brain. So the frog was brain dead, but his body organs were still working, and so his heart was still pumping and so forth. But I left him on the table there after the experiment and came back the next day. And all I had to do was, his heart is stopped, but all I had to do was just touch his heart, and the heart would beat again. I'd touch it again, and it would beat. Because on your heart, you've got a little mini brain called the sinoatrial node, and it sends electrical impulse around the heart to make it contract. You have electrical impulses going throughout your body. So understanding electricity is very important. This little section is not too hard. We've got this calculation here, or the equation for calculations, and an example here. And this video is just for this first part, and we'll post another video for the second part. So here you can see the questions, and there you can see the answers.